Hello students, welcome to the digital signal processing course. In this course, we are right now discussing the topic that is overlap save and overlap add method. So let me write down here statement. Let's say find the output that is y of n of a filter. Its impulse response is, let's say, h of n is equal to 111. This is what the impulse response for the filter, and the input signal for this is x of n is equal to 3 minus 1 0 1 3 2 0 1 2 1. This is what the input sequence. So we need to obtain it either by using overlap save and overlap add. So let's discuss first of all overlap save method. So we will see how to find out this y of n by using overlap save method. So let's discuss this for first method. So for this, as it is provided, h of n is equal to 111. It means m is equal to 3 is already given to us. We need to decide the value of n is equal to l plus m minus 1. So n and l, these are the unknown quantities. Normally we need to take the L greater than equal to M. Let's say right now we are assuming that the L is 3 and M is also 3. So from this value of N which we will get, that is nothing but 5. So N will be nothing but 5. It means obviously M minus 1 is equal to 2. So as we discussed overlap save method, in case of the overlap save method, it is quite obvious that x1 of n, this is nothing but the first part of x of n, which will be nothing but firstly m minus z 1 zeros are to be added. Here it will become 0 0. Next sequence which we need to go for, that is nothing but 3 minus 1 0. This is nothing but l, that is value 3. Similarly, these are nothing but the number of zeros which we need to append, that is m minus 1. So this is how this l plus m minus 1, that will give the value as a n. So this is for x1 of n. Similarly, when we calculate it for x2 of n, it is nothing but minus 1 0. That is the m minus 1 values of the previous sequence. So these values minus 1 and 0, that will be carried over here. Then 1 3 2. So this is how this rest of the values we need to write. So this 1 3 2, these are nothing but the values which we have taken from the sequence. So after that, x3 of n will be prepared. Again m minus 1 means two values from x2, that is 3 and 2. Last two values we need to just write it here, and next value, that is 0 1 2, will be written here. Similarly, the next sequence x4 of n, it is nothing but 1 2, last two values will be taken. Next it is 1 2 zeros we need to append because the sequence ends at 1. Once this x4 of n is done, later on we need to obtain the related y1 y2 y3 and y4. For getting y1 of n, what we need to do, we need to take x1 of n 5-point circular convolution with h of n. H of n is 111, which means we need to append two zeros to it. So this is nothing but actually, in short, 0 0 0 0 0 3 minus 1 0. It will be 5-point circular involved with 1 1 1 0 0. So let's find out this circular convolution for this sequence. It can be easily obtained with the help of the method which we have seen as a matrix method. So I will just write down here, let's say 11100. This is 11100 and 11100, 11100. Lastly it is 11100. Later on, no need to shuffle it. Multiply it to this 003 minus 1 0. So after multiplication it will give the values. Let's check it. This is 0 0, then it is minus 1, and this is 0 0 0 and 0. This is 0. Then next this is 0 plus 3. This is plus 3. Next it is 0 0 plus 3 minus 1. It means it is 2. Next 0 0 plus 3 minus 1, that is 2. So this is what the sequence which we will get. So this is how this y1 of n is obtained for the given x1 of n involved with h of n. The same kind of practice has to be repeated for calculating, let's say, y2 of n. Let me write the y2 of n directly. This y2 of n, after circularly convolved with x2 of n with 5-point circular convolution with h of n, it will give the value. This value is nothing but 41046. This is what the value. Similarly, y3 of n, that is nothing but x3 of n circularly convolved with h of n, and it is nothing but the value 6 7 5 3 3. And lastly y4 of n, that is nothing but 1 3 4 3 and 1. So this is how all the values are being calculated, that is y1 y2 y3 and y4. Now the question comes, what to do for all these values. So we need to rearrange all these values. Let me write it. This is y1 of n. I will write down the y1 of n, that is minus 1 0 3 2 2. This is what the y1 of n. Once we prepare y1, let's write down the values for this as. Which are these values for the y1? It's two values, initial values, that is m minus 1. These are to be discarded. Let's write down for the y2 of n first of all, then we will decide which values are to be discarded. So this is 41046. Then y3 of n is nothing but this third sequence, which is written as a 6 7 5 3 3. Okay, this is what the third sequence. Next is y4 of n, which is equal to, let's write it here, start it from m minus 1 overlapping sequences. So it will be 1 3 4 3 and 1. Now as we know, y of n is the combined effect of all these y1 y2 y3 and y4. Therefore we need to discard this m minus 1 appended values from each y1 y2 y3 and y4. So the resultant sequence which we will get for y of n after discarding this minus 1 0, it will be 3 2 2, then 0 4 6, then it will be 5 3 3 4 3 1. So this is nothing but the y of n for the given calculations. And that is how we are using the overlap save method. In the next lecture, we are going to see what is overlap add method and how to calculate the result for the overlap add method. So thank you everyone. Thank you very much.